In this video, we'll take a look at the Microsoft.NET interface for LEGO Mindstorms and build an application to program one of these guys to perform some basic tasks.
Let's start off by taking a look at what comes in the box with the Microsoft.NET interface for LEGO Mindstorms. The first thing you'll come across is the class library, which has been developed in C++ CLI. This wraps LEGO's Win32 Ghost API, providing a smooth interface to access functionality on the Mindstorm. The classes that are exposed by this class library, such as the RCX, RCX Motor, and RCX Sensor class, have the kind of properties, methods, and events you'd expect to see based on their hardware counterparts. A lot of work has been done to provide an abstraction layer so that events can be raised in a model where events are not native to the RCX itself. Finally, you'll see that there are 3 sample applications available in the 4 major .NET languages. These include the music sample, the remote control sample, and the roverbot sample, which illustrate how to perform a series of tasks from different perspectives. The RCX class is the main entry point to access anything on the Mindstorm. It's the only class you can instantiate because it has a public constructor. Other classes, such as the RCX Sensor and RCX Motor class, are designed to be used through the RCX class itself and cannot be instantiated because they have internal constructors. In addition to the motors and sensors, you'll also see that the RCX has methods so that you can play tones as well as system sounds and even send messages out to other RCX bricks. Finally, there are 2 events that are available, the battery power changed and the message received events. Those events are likely to be raised on separate threads, so be aware of that when building applications. The RCX Motor class provides access to the motor on the RCX itself. It only contains 2 properties. The power property is the one you'll primarily interface with. When you set the power positive, it moves the engine or the motor forward. When you set the power negative, it sets the motor negative. And when you clear the power to 0, it turns the motor off, but not fully off, is that it's not locked. It actually ends up in a float state, where if it's on an incline, it can still roll down a hill. If you want to lock the motors in the off position, call the off method directly. The RCX Sensor class provides access to the properties available on the specific sensors available on the RCX. For example, the value of a touch sensor will be 0 or 1. The value of a temperature sensor will range based on what the sensor is available to it. It's very important to explicitly set the sensor type of an RCX sensor if you want to use it. Sensor types that have a value of none, which is the default value, will not be pulled off from the RCX, and as a result you will not get value changed events, and the value property itself will not be updated. As mentioned before, these classes cannot be instantiated directly, but must be accessed through the RCX itself. So now let's take a look at the process of building a LEGO application using the Microsoft.NET interface for LEGO Mindstorms. We'll start off by creating a new project. We'll use Visual Basic and create a Windows application, and we'll call the app My LEGO App. Visual Studio will go ahead and create the code required for us to get started and leave us with a nice blank form. And the first thing we're going to do is we're going to take some basic files that are required in order to use the application and copy them from a known directory into the debug inside our LEGO application. Now these 4 DLLs here serve different purposes. The first one we'll talk about is the LEGO RCX DLL, which is the managed DLL that provides all the classes that we'll be accessing. It wraps the Ghost API DLL, which knows how to take LEGO assembler codes that are passed from the LEGO RCX DLL and wrap them up inside infrared packets that can be sent to the LEGO RCX for processing. The 2 PBK DLLs, COM32 and USB, provide the support for using serial ports and USB ports respectively. In our case, we're only using USB, so we don't need to carry the COM32 DLL with us, but it's always a good practice to keep them together. Switching back to the development environment, we're going to go ahead and add a reference to that DLL that we just added into our directory. We're going to navigate down into the bin directory, and then into debug, and we're going to grab the LEGO RCX, and we'll switch to code view very quickly so the way we can add a reference to that class library. We're going to switch back now to our design mode, and we're going to add two buttons. The first button is going to tell the LEGO RCX to move forward, and the second button is going to tell it to play a system sound. If we jump back into code view now, we're going to add an instance to our class. It will be the RCX. And we're going to instantiate this inline as a new RCX object. By default, this will try to connect up via USB, which will succeed for us. Otherwise, you'd want to explicitly set up code that would create the RCX and have it connect to either serial or USB. Now we're going to do a little bit of a cheat here. We're going to tell the RCX that we want its motors to move forward. So we're going to set the power of each to 8. And rather than setting up a call to a timer that would call us back after a second, we're going to use the threading class library to call into the thread sleep. And we're going to have it sleep for a second here. Now this, of course, is not a good practice. We're only doing that because we want to simplify the amount of code we're writing here for the sake of this demo. But ordinarily, you wouldn't want to have the application hang while it's waiting for something to be completed on the RCX itself. Now we've set up the motor so that way they will move forward for 1 second. We're going to go back to that application again, and we're going to configure the UI so that we can play a system sound when somebody presses the second button. So on the RCX, we're going to say play system sound, and we're going to have it play the fast upward tones. Each of these enumerations maps to a specific LASM configuration command that is built into the firmware on the RCX. So those 6 different system sounds are actually available natively in LASM on the device. So we're going to go ahead and we're going to build a solution, make sure we don't have any bugs. And now we're going to start off by running the application. And this will launch our app. It'll make the connection over the USB, and we'll press the move forward button. And the RCX, as you can see, will move forward for 1 second, and then we'll press the play system sound button, and it will play the system sound. So this was the process of going through and creating a very simple application that performed very basic tasks. In our next video, we'll take a deeper look at the 3 sample applications that come with the Microsoft.NET interface for LEGO Mindstorms.